Very good morning to one and all. This is two-port networks in the subject of network analysis of electrical engineering. This one being very important topic, and it's a subject itself also, two-port networks. Before we understand two-port networks, let us understand what is meant by one-port network that we have studied till now, and we know it by default. The one-port network is shown by this diagram. You can see this, and the definition being and the example being, this is one-port network is two-terminal electrical network which have the facility of entering of current through one terminal that leaves through the another one. That is so simple. That is so simple. Examples: resistors, inductors and capacitors are the example of one-port network. Why? Because as each one has two terminals. See this? This is the resistor. Can you find another way that if current is entering this position, it will definitely leave this one. There is no another path to leave. Of course, this may sound absurd, but yes, we are analyzing this. We are gradually moving towards two-port networks where we are going to graduate from this concept. Let us look towards the inductor. This is our inductor. This is our inductor. Current entering here, current leaving here. That means what? As each one has two terminals, terminal number 1 and terminal number 2, 1 and 1 dash. As per the definition, inductor is a one-port network which is having two terminals in which current enters through one terminal, and leaves through the another one. It is visible here, and same is applicable for the capacitor. There is no exception for the capacitor. So what is special in two-port networks? Two-port networks is very much important when we are going to analyze certain parameters in power systems transmissions. We'll see it later on, but let us just finish this one-port network. What is this called? Port 1 and port 2. This is our terminal number 1, and this is our terminal number 2. Let us call it 1 dash. This whole thing is your port number 1, port 1. This is having terminal 1, and this is terminal 2. This is terminal 1, this is terminal 2, this is terminal 1, this is terminal 2. I'm trying to make it so easy for you that you may not face problem to understand this. One thing more is there. These terminals are the input terminals in which source is connected. These terminals are the input terminals in which the source are connected. The source are connected actually. Impedance and admittance parameters are generally determined at these terminals. What we are determining at these terminals, let me write this. That is, impedance and admittance are generally determined at these terminals. which is also known as driving point impedance. This is very much important. Driving point impedance and the driving point admittance. Driving point admittance. Now we have understood the so-called one-port network. Why? Because we are actually determined to understand this two-port network. Before going to two-port network, we have actually studied what we have studied till now, that is one-port network. This is actually we have studied till now. Now, let us move towards two-port network. That is two-port network. How it looks like? It looks like that one more port is added to the previous one. This is port 1. This is port number 2. This is port 1 and this is port 2. And this is your entire network of the concern. This is your two-port network. One may ask, sir, there is a three-port network or four-port network or so on. Yes, there is also called N-port network. N-port network. N may be 3, 4, 5 or so on. It may look like this. It may look like this. This will have n number of ports. This will have n number of ports. Okay. This is your network. This is your port 1. This is your port 2. This is your port 3. And this is your port N. Nth port. Nth one. Though it is looking like port 1, but we can have a model of n number of ports of a system, of a network system. Now let us move towards two-port network definition. That is there are port 1, that is 1 and 1 dash, port 2, that is 2 and 2 dash. So what we are having here, we are having this is I1, this is I2. Here it is defined plus minus V1. Here it is defined the same polarity plus minus V2. It is defined V2. It is defined V1. Here the rectangular box, the square box or rectangular box represents the network that is containing so many branches, so many network elements it includes. So do not get confused that what is this rectangle box or a square box is comprising. This is actually, we are actually concerned about studying about this port and this port. We have studied this thing in earlier classes. So we are interested in to understand the port number 1 and port number 2. First of all, we will define and study its nomenclature, and then go for the parameter. Parameter means the variables, how variables are defined here, and how variables are actually here defined as independent and dependent. We'll go for independent and dependent variables in coming slides. Have some questions, please, dear students. So we were talking about this rectangular box is containing so many of elements, so many of branches, and the branches are connected, so there will be nodes. Of course, these elements are connected, so there will be nodes and have their own currents. This will have currents, and there will be have a voltage defined under this rectangular box. There will be defined voltage under this rectangular box. You must agree this. Okay. But as far as two-port network is concerned, this current and voltage inside this rectangular box is not so important. Because we are actually emphasizing the current and voltage defined at port number 1 and the current and voltage defined at port number 2. This is your current defined at port number 1, that is I1. This is your current defined at port number 2. See the nature, 1 is entering and 2 is also entering. See the nature of voltage 1. So defined plus minus, see this, and this is plus minus V2. This is the basic definition of two-port network. Wherever we are going to face problem and situation of two-port network, we will refer this standard definition. Okay. As I have told you that current and voltage inside the rectangular box, which is actually I have written network, is not mentioned here. Okay. So they are not specified in two-port networks representation. In the whole representation of two-port network, this is not represented. The inside, which is not represented, the inside current and voltage of this network. What is represented? Please listen it. The represented is this one and this one. Okay. So let us move towards the variables of two-port networks. Actually, I have given you in my discussion the variables of two-port networks, and that is for port number 1, the variable is this one. I'm going to specify with a different color so that you'll feel it very easy to locate. For the port number 1, the variable is V1 and I1. What is the variable? V1, comma I1 for the port number 1. Okay. For the port number 2, the variable is this V2 and current I2. This current I2. So I'm writing it. For the port number 2, the variable is V2 and I2. So whenever we are going to face the problem and situation of two-port network, automatically we'll consider the variable defined on port number 1 is V1 and I1. The variables defined on port number 2 is V2 and I2. We are actually going to represent all the parameters of these two-port networks with the help of this V1 and I1 and V2 and I2. This is your variable representation of two-port networks. Okay. This one for port 1 and this one for port number 2, this is for port number 1. So let us start the parameters of two-port network, which is actually the core of this two-port network. This is actually the mathematical tool and the equations actually given by the two-port networks of network analysis, which will be actually employed or applied for practical problems or the theoretical problems as well. What is meant by parameters? There are set of independent and dependent variables. We'll see this. Let us understand the parameter. That is parameters of two-port network. Parameters of two-port networks. The first one is that is called open circuit impedance parameter. That is open circuit impedance parameter. Open circuit impedance parameter. That is also known as Z parameter. Okay. The voltage current relationship is, that is the VI relationship is given as V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21. We are writing this equation for port number 2. Why? Because V2 is defined at port number 2. Please take care of it. And see this. This is I1 plus Z22 I2. Call it equation number 1 and call it equation number 2. Dear students, just analyze one thing. You may ask me questions that, so you told me that there are some set of dependent variables and independent variables. What are those? Yes. See this. This is V1, this is V2. The value of V1 and the value of V2 is depending on something else. This is your parameter, Z parameter. Okay. Z11, Z22, Z11, Z12, Z21 and Z22. Now if we insert or find the value of I1 and I2, if we can find the value of I1 and I2, the value of V1 may be determined or can be determined successfully. Yes or no? This is so simple. So this I1 and I2 are independent variables. Yes. This I1 and I2 are independent variables. Independent variables. Why I'm explaining all this? Because in further analysis or in some of the numerical problems, there are actually this terminology used, that we have independent variables and we have dependent variables. Okay, and this V1 and V2 are dependent variables. Dependent variables. Both are variables, but the nature is one is independent and the another is dependent. Okay. Z11, Z12, Z21 and Z22 are the impedance parameter or Z parameter. Are the impedance parameter or Z parameter. This is your impedance parameter or Z parameter. See this. See this. This one and this one. This is your impedance parameter or Z parameter. Okay. This is Kirchhoff's voltage law. The equation number 1 and the equation number 2 are actually Kirchhoff's voltage law. This is from the KVL equations. Let us find the unit of this Z11, Z12, Z21 and Z22. Okay. For determining the value of Z11 or Z12 or Z21 or Z22, we need to open one of the two ports. We need to open one of the ports. We have two ports here, so we are going to open the port. Let us see. We are going to open one of the ports. See this, dear friends, dear students, this was your network. Okay. This is port number 2, this is port number 2, and this is port number 1. Okay. This was actually I1, this was actually I2, and this is plus minus V2, and this is plus minus V1. We have seen this. No problem. So this is the rectangular box having so many number of branches and elements, nodes and currents and voltages, and we are not actually concerned about this inside currents. Okay. Now open port number 2. We are going to open port number 2. Open port number 2. Open port 2. Okay. So we have only port 1 here also. So Z11 will be equal to V1 by I1. When we have opened port number 2, it means what? The current I2 will be 0. Of course, this is 0. From where I am writing this equation? Dear friends, dear students, just see equation number 1. Equation number 1 was V1 is equal to Z11 I1 plus Z12 I2. This was your equation number 1. When I have zeroed or opened port number 2, it will become 0. So this entire vanishes. Remaining is V1 is equal to Z11 I1. From this, I am writing this Z11 is equal to V1 upon I1 under the condition that I2 is equal to 0. This is your Z11 is equal to V1 by I1. And dear friends, please take it very seriously. This is called driving point impedance at port number 1. This is called driving point impedance at port number 1. And the unit is, see this unit is Z11 is equal to V upon I. Although it is V1 upon I1, So the unit is exactly what? Ohm. The unit is ohm. This is your input impedance. This is your input impedance. Okay. So please take in mind what is your input impedance value. So it is Z11 is equal to V1 upon I1. It is your input impedance value. Now likewise Z21. For the Z21 we are going to have this equation. Okay. We are going to zero this I2. Why? Because we have actually opened port number 2. If port number 2 is opened, so I2 is not flowing there, the value of I2 will be 0. So if the value of I2 is 0, so V2 will be equal to Z21 I1. Okay, the value of Z21 is equal to V2 by I1 under the condition that I2 is 0. Why? Because port 2 is opened. We have opened port number 2. Port number 2 is open. The current will vanish but voltage will be there. For open circuit, voltage exists but current vanishes. Current becomes 0 and voltage is there depending upon the circuit parameter and situation. So it is called transfer impedance. It is called transfer impedance. And the unit is ohm in ohm. Dear friends, we have opened port number 2 and calculated two of the parameters among four parameters. Among Z11, Z12, Z21 and Z22 we have calculated this one and this one, that is Z11 and Z21. We have calculated only those parameters whose value was not dependent on current I2. See this. Okay. Now the remaining two can be calculated by the similar process. We are going to open port number 1 and will remain port number 2 as it is. See this. This is your network. This is your port number 2. As the definitions, this is your port number 2. This is V2 defined. This is I2 defined. This is port number 1. This is V1 defined and this is I2 defined. Now we are going to open this port number 1. Port 1, we are going to open this port number 1. What will happen? Sorry, this is 1. Going to correct it. Port number 1 will have current 1. Okay. So this is your I1. When it is opened, I1 will be 0 or equal to 0. Okay. Only I2 will exist here. This is your network. As before, we have seen this. Likewise, it is Z12 is equal to V1 by I2 when I1 is 0. Okay. This is called transfer impedance in ohm. This is called transfer impedance and the unit is ohm. Likewise, Z22 will be equal to V2 by I2 when I1 is equal to 0. This is called driving point impedance at port 2. So Z22 is your driving point impedance at port 2, and the unit is, you can see the unit, it's in ohm, that is V upon I, and the unit is ohm. This is driving point impedance at port number 2. Driving point impedance at port number 2. Dear friends, dear students, please keep in mind that we have simultaneously found the value of Z12, Z22, and see the previous slide, Z11 and Z21. First we have opened port number 2, and then after we have opened port number 2. Okay. Now the equation number 1 and 2 which we have written here, see this equation number 1 and 2. This is equation number 1 and this is equation number 2. This can be written in matrix form like this. I am going to write equation number 1 and 2 in matrix form. That is V1, V2 is equal to Z11, Z12, Z21, Z22 and I1 and I2 in the matrix form. In matrix form. Equation number 1 and 2. Now we have to determine the impedance matrix. Determinant of impedance matrix. Determinant of this impedance matrix of impedance matrix. How it is? This is delta Z is equal to, how it is calculated? Just see this. This is Z11 into Z22 minus Z21 into Z12. That is Z11 into Z22 minus Z12 into Z21. This is a determinant of the impedance matrix. Please keep in mind. For reciprocal networks, that is, which will have bilateral property, for the bilateral property, we are going to have the condition that Z12 must be equal to Z21. Please keep in mind and make it a note that for, as far as two-port network is concerned, for reciprocal network or For bilateral property, the parameter should be like this. The z parameter should be like this. The value of z parameter must be like this, or in simple word, the value of z12 must be equal to z21. Okay, the value of z12 must be equal to z21, or in another word, this diagonal elements must be equal. This diagonal elements must be equal. This one must be equal. Okay, then only we can have that reciprocal network exists and it have bilateral property. This is also the condition for passive network. If this is satisfied, that this is passive network. If this is satisfied, that this is passive network. If network contains any control source, then network will not be reciprocal. If controlled source is present, if controlled source is present, then this implies it will not be reciprocal. It will not be reciprocal. It will not be reciprocal. I'm going to cross it. It will not be reciprocal. If control source is present, then it will not be reciprocal. Okay. It means what? For such networks, it will be like your Z12 will not be equal to Z21. Okay. If control sources are present, the condition will be like this. Z12 is not equal to Z21. Now we have actually used the word control sources. Now let us understand, if we are going to represent this whole parameter, Z parameter, in equivalent circuit, how it will be like this? How it will be? It will be, see this. Dear friends, this is your 2-port. We have taken this example. This is your 2-port. Okay. This is plus minus. V2 is defined. I2 is defined inward. I1 is defined inward. This is plus minus. This is V1 and V1 is defined. V2 is defined, and this is your network. And we are having it port number 1, and this is port number 2. Let us be more clear. This is terminal 1. This is terminal 2. This is terminal 3 and terminal 4. Now I am going to draw the equivalent circuit by using Z parameter. Equivalent circuit by using Z parameter. We'll have equivalent circuit of this network, this 2-port network. This is from the equation. You must be realizing that, see this, I'm going to refer you the equation number 1 and 2. This is equation number 1 and 2. This is equation number 1 and 2. See this, I'm going to use this technique. How? See this. This is Z12, and which is depending on current number 2, I2. This is plus minus. This is This is Z11. This is plus minus V1 is defined here. V1 is defined here. This is current I1 flowing inward. This is your this is plus, this is minus, this is Z21 and the current will be 1. This is Z22. This is the self impedance of port 1. This is the self impedance of port 2, or this is also known as, I have defined here Z11 as, see this. What is Z11? Z1 is your input impedance. Z11 is your input impedance. And what is Z22? Z22 is your driving point impedance at port number 2 and the unit is ohm. See this? This is your plus, minus and V2 is defined here earlier. This is current I2 defined here. This is your equivalent circuit by using Z parameter. This is your equivalent circuit by using Z parameter. Okay. You can see that this is your current dependent voltage source. This is also your current dependent voltage source. The current I2 is flowing in port number 2 here, and in this current dependent voltage source the current I1 is flowing here. Okay. So this is your complete description and the explanation of Z parameter. Z parameter is very important. Now we are going to study about short circuit admittance parameter, Y parameters. That is short circuit admittance parameter. Admittance parameter, that is, or that is also known as Y parameter. That is also known as Y parameter, in which we have KCL equations. In Z parameter we were having KVL equations. Now see this, it is defined as I1 is equal to Y11 V1 plus Y12 into V2. I2 is equal to Y21 V1 plus Y22 into V2. Quality question number 4. Sorry, quality question number 3. Quality question number 4. Now see this. There are some set of dependent variable and independent variable like we have discussed in Z parameter also. This is I1, this is I2. This is dependent variable. This is dependent variable, and V1, V2, here also V1, V2 are independent variable. That is, dependent variables are I1, I2, and independent variables are V1, V2. That means what? That is, on the value of V1 and V2, the value of I1 is dependent. On the value of V1 and V2, the value of I2 is dependent, and the circuit being the same, the network circuit being the same like this.